In this demonstration, you'll learn how to use expressions to define a location, a boundary condition property, and a result. My project consists of a fluid flow template set up to analyze flow through a nozzle. I've already set up analysis parameters and generated my mesh. Now I'll set up a boundary condition in the physics region. First, I'll right-click to add an inlet boundary condition. I'll assign it to the in selection set that I've already created. Now I'll specify a reference frame that is centered on the inlet in order to set up a velocity profile. I want to set the z-axis parallel to the body of the nozzle, so under Origin and Orientation, I'll set axis 1 to z-axis. I need to create a named expression to use in defining the magnitude for this boundary condition, so I'll go back to the study and add an expression in the Named Expressions and Values area. I'll set the name of the expression to inlet val and the value to 10 meters per second. Units must be surrounded by square brackets. When you type the open bracket followed by M, you can select the correct units from the list shown. I'll go back to the inlet boundary condition now. For the magnitude, I'll enter an expression that varies the velocity with respect to the radius of the inlet. This uses the inlet val expression I've just set up. Note that the expression will be evaluated with respect to the local reference frame of the boundary condition. Next, I'll right-click to add an outlet boundary condition. I'll assign it to the out selection set that I've already created. And I'll set the static pressure to 0. Next, I'll right-click to add a wall. You can see that by default, AIM has assigned the wall to the faces returned by the default walls function. This expression, which returns all of the unassigned faces of the model, is automatically assigned to the location of this boundary condition. I'll now solve the physics and evaluate the results. You can see that for the fluid flow template that I used in this case, AIM supplies a velocity result by default. Now I'll calculate the average velocity magnitude over the inlet in two ways. First, I'll add a calculated value result. In this result, I'll use the function calculator to build the expression. When I evaluate this calculated value, the result is 3.5739 meters per second. Now I'll add another calculated value result. And in this one, I'll enter the expression directly into the result. When I evaluate, you can see that the result of the expression that I entered directly is the same, 3.5739 meters per second. This concludes this demonstration of expressions used to define a location, a boundary condition property, and a result.